This video is recorded to help my students to understand binomial distribution and how to use Excel to calculate binomial distribution. We use this example to demonstrate a quality control expert at a large factory estimate that 5% of all the batteries produced at the factory are defective. The other 95% are not defective. 6 batteries are randomly selected, and then each is tested to see if it is defective. Use this situation to answer the parts below. A. Recognize that there is a binomial situation. Why? Because first, we have fixed number of trials, 6 trials. Second, each trial have 2 possible outcomes. One is defective, another is not defective. So we can call defective is a success, not defective is a failure. Why? Because we're interested in how many is defective. So given the mean of success and failure in this context, so we say success is the battery is defective. So the failure is the battery is not defective. Okay. Then we say why we use battery is defective with success, because we're interested in say how many battery is defective, because we want select a battery test for defectiveness. So we choose if the battery is defective, we have a success. Okay. Next, give the value of N, P, and Q. So we know N is 6. You have 6 batteries, right? P is 0.05. The defective percentage is 5%. And Q is 1 minus P, 0.95. Okay. C. Constructed a complete binomial probability distribution for this situation in the table out to the right. So that X is a random variable. X denotes the number of battery that is defective. So since you have 6 batteries, so your X could have value 0, 1, 2, 3, 4, 5, 6, which means you could have 0 battery is defective, or 1 battery is defective, or 2 batteries are defective, or 3 batteries are defective, and so on. Now the probability Px, that means the probability of X battery is defective. We can use the following formula to do this. This equal binomial distribution. If you type this, you say the first argument is number of success. So your number of success is in J7. Then second number is the number of trials. We have 6 trials. Then the probability for success, which is 0.05. And the cumulative, you need to choose false. When you choose false, means I want to calculate Px equal J7, which is 0 in this case. So we want to calculate P probability of X equals 0. So we choose cumulative is false. Now we just drag it down this formula to the rest of the cells. Okay. Notice this value. What does this mean? This means the probability of X equal 4. That means the probability of 4 batteries are defective. This number is very small. Notice this notation. 8.4609 multiplied e to the negative 5. This means 8.4609 multiplied 10 to the negative 5 power. This is a very small number. So this is our table. You can verify this really is a probability distribution. You can add up all those probabilities. You add up from K7 to K13, right? So if you add up those, you have got 1. Okay. Use your table, find the probability that exactly 1 of 6 random selected battery is defective. So you need to find Px equal 1. This is equal Of course, you can directly from the table, which equal K8. Equal K8. I should type equal. This is the probability. Or you can recalculate it again if you wish to. You can recalculate it, use the binomial distribution. This time you know your number of success is 1, the number of trials is 6, and the probability for success 0.05, and the cumulative is false. False, you can type 0 here, so you've got the same number. So find the probability that at least 3 of 6 batteries selected are defective. So I need to find a P x at least 3, so which means x greater than 2, or you can say x greater than or equal to 3. This will equal. Now I have two ways to do this. One way is since px greater than equal to 3 is px equal 4, or px equal 3 plus px equal 4 plus px equal 5 plus px equal 6. So I can use sum. This sum, I want to add up all those 4 values. So that's giving me the probability. I also can directly use the formula to calculate. This time I will do this. I will first use 1 minus the binomial distribution. This time I let success equal 2. Trial still 6. Probability for success is 0.05. This time I make cumulative equal 2. Now what this means? This means this formula binomial data distribution 2, 6, 0.05 true means you calculate the probability of x equals 0, x equals 1, and x equals 2 because I wanted cumulative. So from 0 up to 2. Now then I use 1 minus it is complement. So in this case, 1 minus those will become the probability for x not 0, not 1, not 2. That means probability for x greater than or equal to 3. So you should get the same result. You say we got exactly the same result. Next, find the probability that less than 2 are defective. So this will give me px less than 2 equal less than 2. That means is p0 plus p1. So I have two ways to do this. One way is I use k7 plus k8. That means p0 plus p1. Or again, I can use the formula directly. Binomial. Sorry, I should type binomial. Binomial distribution. This time, my number of success is 1. Trial still 6, 0.05. And the cumulative is true. True, I can just type 1. 1 means true, 0 means false. Okay? So I should get the same result, you see. Now, find the mean of the standard deviation of the binomial distribution. The mean equal n multiply p. So your n is 6, your p is 0.05. Okay? Then your standard deviation equal, this will equal square root of n, which is 6, multiply p, 0.05, multiply q, 0.95. So that's your standard deviation. Now, writing a sentence, interpret the meaning of the mean value found in the previous step. Now, this 0.3 means if we repeatedly to withdraw random pick 6 battery as samples, then for each sample we count how many batteries are defective. Then the average for all those samples will be 0.3. That means on average, each sample has 0.3 battery is defective. Now, last question. Is it unusual to have all 6 of the batteries selected be defective? If you want all 6 batteries be defective, the probability is this. this is 1.5625 multiplied 10 to the negative 8 power. Is a very, very small number. So we know it's unusual. Okay, if you have any questions, please give me an email. See you next time.